Hi everyone. The topic of this session today is real end user monitoring in Java Diagnostics. My name is Yuta Takatsu. I am one of the product managers in the Enterprise Manager product management team. Here's today's agenda. I will start with a brief introduction, then talk about the details of the real user experience insight in Java Workload Explorer, followed by a quick product demonstration. Then discuss JVM Diagnostics in more detail. Lastly, I would like to mention the JVMD solution we have for Kubernetes. Enterprise Manager offers a wide range of features designed to address various problems. And one of the questions we receive from time to time is about the APM solution in Enterprise Manager. This is because there is no specific product in Enterprise Manager with APM in its name. That is what I would like to talk about in this session. The APM solution in Enterprise Manager includes two essential product features: Real User Experience Insight, or RUEI, and JVM Diagnostics. RUEI is a passive network monitoring tool that captures your entire production application traffic. By storing this information in an Oracle database, you can later analyze your customer's experience and confirm the existence of any problems. RUEI is integrated with JVM Diagnostics feature in Enterprise Manager. This collaboration becomes especially useful when identifying the root cause of the performance issue. By linking the problematic session that RUEI found with its underlying JVM information, you can narrow down the execution data to the request, method, or even line number in the Java code. As for the licensing information, RUEI is licensed either by a standalone or as a part of the Application Management Suite license for eBusiness Suite, Siebel, or PeopleSoft. So if you have Application Management Suite license for these package applications, you already have RUEI. JVMD is licensed separately and requires WebLogic Management Pack Enterprise Edition. So let's start by knowing what questions RUEI can answer. On the left-hand side of the screen, we have an internal business application, and there is an IT administrator who manages that application. And say there was a page error, so the user of this application could not load the page. The users reported the problem to the administrator. However, the administrator could not reproduce the problem. She is wondering what was the error that the users were seeing. Another example is an online shopping website, and there is a business application owner wondering how many customers actually came into my store and what percentage of them actually purchased my product. So these are the questions that RUEI can answer. IT administrators can see the full session report of what exactly happened during the error time. She can further diagnose the issue using the JVM Diagnostics feature and drill down to find the root cause. And business application owner can see the traffic statistics, and based on the KPI thresholds, she can configure RUEI to raise an alert and receive email notifications. So this is a high-level introduction to what questions RUEI can answer. The screenshot in this slide shows a session diagnostics page where you can see the list of user sessions. This list is already filtered by a specific application, which is a wine cellar application, and also filtered by a user ng operator, and by a specific client IP within a specific range of time. Say you want to see the details of the first session in the list. You can click the icon in the info section, and that opens up the full session replay page. It has a request and response header information, response content in the raw HTML, also in the rendered HTML. So if a user says he or she could not open the page because of the server error, and if you happen to be the person to investigate that, this functionality allows you to go back the time and show you the page which the user saw in his or her session. So you are able to see the session details in HTTP level. But in case of problems, you also want to further diagnose that by tracing the session down to the thread level. This page allows you to do so by clicking the red O icon and punches you out to open Java Workload Explorer page, where you can perform deep dive diagnostics for the selected session. So let's take a closer look on that. Here you open the Java Workload Explorer homepage. There is a bar chart on the upper side of the screen, and each bar represents the thread that are grouped by the state, such as database weight or CPU weight. You can see by the color what resource the thread is waiting for. Down here in the table shows the page request information that are running in a selected time range. It shows how long they are running, how many times they appear, and resource utilization information such as memory allocation or CPU usage. And this table is multidimensional. By clicking the icons in a toolbar, it displays the information for other dimensions. So currently, it's showing request information, but you can select the different icons in the toolbar to show methods, threads, or database resources, for example. And one of the popular functionalities of this tool is that it allows you to compare the workloads. Now you see in the upper side of the screen, there are two bar charts displayed. And in the table on the lower side of the screen, each column has two sets of data, current and baseline, side by side. So basically, you can take a snapshot of the baseline workload, which is usually a stable workload, then bring that onto the screen for comparison. From there, you can carefully analyze what would be the difference between the two. And as mentioned, the table view is multidimensional. If you cannot find the root cause in one dimension, you can switch the view to other dimensions to find the difference. So in this case, you open a tab having method information. And here you could see a method present in the current workload. However, it does not exist in the baseline workload. This implies a change and could be the root cause of the slowness in application. You can further see the call stack information to see in which Java file the method resides. So this was how you can use RUEI and Java Workload Explorer together to diagnose application performance issues in your production environment. Now let's see this in actual product. What I have here is the Enterprise Manager 13 open in my screen, and here is the page that shows RUEI monitoring and application. And this is a business applications which we use for demo purpose, but the monitoring capabilities which RUEI provides are generic to any application. So either that is a homegrown or packaged application that you are to monitor with RUEI, what you see in this demo is generally applicable. So you can expect a similar experience regardless of the types of applications. So what we can see in this dashboard, in the center of the screen, at the lower side, there is a multi-level pie chart. This is a usage and violation overview section. And this image is the presentation of all the pages that are accessed in the last 2 hours. So the center of the circle is the application layer, which is the wine cellar application that consists 100% of the page views. So I have 11,550 page views in total, and 2,274 are having some kind of violations. I can see the breakdown in the table view, which is showing in the right-hand side of the same section. And the area next to it is the page groups. Here is the online store that consists most of the page views, and the outer layer shows the pages. Here I click the wine search, which has the largest number of clicks. And as I click the chart, table view also gets updated. So this page has 1,175 application-side violations and also 104 user-side violations, and I can also see 3 server errors. And I can further drill down to see the instance level details by clicking the metrics link. Here I can see the access details for this specific page, which is the wine search. So looking at this first row, user ID is NGuser27. Here is the time accessed, and here is how long it took, which is 90 seconds. And the list is sorted by the time bar column. So this seems to be the slowest page during the last 2 hours. And I see the client abort, which means the user did not wait to complete the page load, which makes sense because it was taking 19 seconds. And I have so many of them here with a similar experience. So something was causing the slowdown of this page. And the search section has filters already pre-configured, but you can add other filters to further narrow down the list. So I recall there were a few server errors showing up in the dashboard view. How can I see them? What I can do is to add a new field in the search section to filter the view for the server errors in specific. So I'm going to select Add Fields, scroll down, and select the server errors. Now I have a new field for server errors. And this will search for the number of server errors per instance. So I'm going to put the number 0 here and redo the search. Now I see 3 entries that are having internal server errors. I'm going to click the camera icon to see the replay data. And this will open an external window. So here you can see the request headers and response header information, also the response content. And you can set up content notification alerts against this information. So you can configure to search for a specific text within the headers or the content. So for example, you can search for the string internal server error, and when it is detected, you can configure to send an alert message to you. And this is raw HTML, but you can also see the rendered HTML by clicking the replay view. So this is the page that was actually shown to the user. Going back, close the external window. So I could see the HTTP level details. Next I want to do is to see the thread level information. So I'm going to expand the first row and click the icon in the info section. And what this allows you to do is to click out to Java Workload Explorer page. So I can see one filter added to this page, and I know this is the execution context ID, which was passed on by RUEI in order to show the relevant data. Let me adjust the time range to 2 hours. And here you go. So this is the JVM information for the thread that ended up in a server error. So I can see by the color, which is purple, that was waiting for the network resource. Next, I want to see what method that was invoked. So I can do this by clicking the Method tab in the toolbar. And here is the method information that is related to the server error we just saw. And I can further see the contact information to see which file the method resides. I'm going to select Action, View Code Tree. I also want to see the line number, so click this as well. Scroll down. And here shows the file name and line number information of that method. Okay, so that was Java Workload Explorer, which is integrated with RUEI and provides diagnostic information. So that was a demonstration of RUEI and Java Workload Explorer. Moving on to the next topic, which is RUEI app in Oracle Cloud Marketplace. Since the year 2020, RUEI is available as a marketplace app in the Oracle Cloud. This app is a pre-configured stack which you can provision the RUEI application in the Oracle Cloud. It contains a RUEI server and a repository on a single Linux host, so you can easily set up the RUEI environment without going through the complex installation steps. And why is that important? Because traditionally, installation and the network configuration are always the challenges in RUEI. The installation may not be that easy, and a physical top device is required for the network configurations. In the RUEI app in the marketplace, we remove these constraints. You don't have to go through the manual RUEI installation steps because you can provision it from the marketplace. Also, you don't have to find a physical top device. Instead, you can set up an L2TP tunnel to intercept the traffic. This is a built-in tunneling functionality in the RUEI app. And the time takes to complete the installation and configuration together is approximately 1 hour. The architectural diagram in this slide is an example of how it looks like when you set up the RUEI app in the Oracle Cloud and monitor an application that is also running in the Oracle Cloud. MTUN in the RUEI instance box is a program that takes care of the L2TP tunneling in the RUEI side. And this is pre-configured in the app, so you don't have to do anything. All you need to do is to run a prescribed set of shell scripts, which will first transfer the virtual network tap software from the RUEI server to the application host, and second, automatically install and configure in the destination host, so that the traffic flows from the application instance to the RUEI instance. The diagram in this example has the monitor's application and RUEI deployed in the same VCN. However, the application can also be in a different VCN, in a different domain, or in a different region. For more information on RUEI on the marketplace, we have a blog and a white paper that walk you through the setup. So the Java workload exporter, which you saw in the demo, is a feature in the JVM Diagnostics. In this section, let me explain a bit more about JVMD regarding its features, characteristics, and architecture. What are the common issues seen in Java applications running in a production environment? Those can be intermittent availability issues, out-of-memory issues, or could be the application crash or timeouts. And those happen because of the situations you did not expect to happen. Then what is the solution for these problems? There are some requirements in order to run diagnostics in production. First of all, the solution has to be always available. No downtime is allowed because this is a production environment. Therefore, instrumentation of the code or recompiling is usually not allowed. And overhead has to be constant, low, and stable. Wide range coverage, secured access, full range of detailed JVM metrics are also required. And these are the features that JVM Diagnostics provides. So JVMD has a solution. Let me briefly show you the JVMD architecture here. In high level, JVMD consists of the JVMD engine, which is a core analytical portion of the JVMD monitoring system, and JVMD agents, which are the data collectors of the target JVM. JVMD agents are deployed inside the managed application servers and collects real-time JVM monitoring data. The collected data is transmitted to JVMD engine directly using SSL. So this is a very high-level picture of how JVMD works behind the scenes. Then what are the key features of JVM Diagnostics? JVMD is primarily designed to be able to diagnose Java performance problems in a production environment. Because it samples the information directly from the application's JVM and uses the information for real-time analysis, there is no need for you to reproduce a problem in a testing environment. It basically eliminates the reproduction process, therefore, it reduces the time to the recovery. JVMD is always on and available all the time. You can find the problems such as the slowest request or the slowest method, or the request waiting for I/O or database calls, or requests using a lot of resources such as CPU or memory. And no application instrumentations or recompiling is needed in order to use this tool. Therefore, no downtime is required to debug the application. It has constant and low overhead, so the impact on the production is minimal, while having complete visibility into the layers in the JVM stack, such as request, thread, heap, and garbage collections. JVMD has its own metric management capabilities. You can set up a metric, which is JVM specific, and configure a collective action to take a heap dump, for example, upon the metric violation. You can do this without stopping the application. It also has integration with Java Flight Recorder, or JFR, so you can start the recording of JFR snapshot from Enterprise Manager, or you can configure it to take the snapshot automatically at the metric threshold violations. You can also export the snapshot, import it into the Java Mission Control desktop application, and run any analysis in there. JVMD has integration with the Enterprise Manager's database performance capabilities. So when you find a JVM thread that is waiting for a database, you can drill down to find a particular SQL that may be causing an issue. And we already discussed the Java Workload Explorer. It provides detailed comparisons across time and servers. And lastly, I would like to mention about the EM capability to monitor WebLogic deployed on Kubernetes in the cloud. You can enable JVM Diagnostics on the WebLogic servers on Kubernetes and conduct deep dive analysis on their JVM. The diagram shows how it works at the high level. As mentioned in the previous section, JVMD consists of JVMD engine, which is a core analytical portion of the JVMD, and JVMD agent, which are the data collectors of the target JVM. Here you can manually deploy JVMD agent inside the WebLogic servers and collect real-time JVM monitoring data. The agent transmits the collected data to the JVMD engine directly using the one-way HTTPS connection. Please note that the JVMD does not use the EMA agent, having its own channel to communicate with Enterprise Manager. As a limitation of this model, the JVMD agent deployment will be lost when the pod is regenerated. Therefore, the reinstallation of the JVMD agent must be repeated whenever such event happens. If you want to have the JVMD agent persist in the WebLogic server, you can deploy in the Docker image of the WebLogic so that the JVMD agent is pre-deployed when the pod is created. This concludes the presentation of real user monitoring and Java Diagnostics. Thank you for watching.